These questions used to do my head in. In fact, I vividly remember seeing one of these on my Year 12 Methods exam and just thinking, getting myself confused with the negatives A's and the positives A's and were they negative numbers, etc., etc., really overthinking it. Now, these types of questions still appear on the exam today, and so what I've done is put together this little video to show you how I make sense of it now. And gee, I wish I had someone who had taught it to me like this back then. I would have been able to ace that question and move on rather than staying stuck for as long as what I did. Let's take this cubic here. We've got x-intercepts of a, b, and c. And so most method students would be able to correctly tell us that the equation for this polynomial is x minus a, x minus b, x minus c. Of course, remembering to include a dilation factor, which I've just called k, but of course you could give it any letter that you wanted to. So nothing overcomplicated there. Now the thing is to remember that it doesn't matter whether these letters here are sitting on the left-hand side or the right-hand side of our y-axis. If I give you an equation like this one with a sitting over here on the left-hand side, that the equation is still the same. It's still x minus a, x minus b, and x minus c. Students are often thrown, though, by the fact that they understand this to be a negative number, and so they want to change this into a plus. Well, let me show you why that doesn't work. If a is the number -3, then using substitution, if we replace just the a there with a -3, that's what creates the positive, because we've got minus a negative number, which creates that change of sign in there. So we don't actually account for the plus here when we're writing out the general rule. It gets accounted for if ever we needed to do substitution. Now that's the case no matter whether there's 1 or 2 or 3 letters on the left-hand side of the y-axis. You can see that the equation doesn't change. In fact, it doesn't matter how many x-intercepts we have or whether they sit on the left-hand side or the right-hand side. In this case, we would end up with the equation of x minus a, x minus g, x minus h, x minus t, and x minus z, with a dilation factor out the front there. Another level of complication, though, occurs when some of these x-intercepts are stated as being negative numbers. Well, here's the thing that you need to do to make sure that you get these ones right. I encourage you to state clearly what the x-intercepts are. So we know that the x-intercepts are a, negative b, and c, and they're read off straight off the graph. Don't worry about whether they're on the left-hand side or the right-hand side. Just tell me what the x-intercepts are. Now don't look at the graph, look here, and from here you're going to generate your equation. So our equation will be k, a dilation factor out the front, and then we've got x minus a, just as we had before, x plus b, and x minus c. And we know that that plus occurs there because in each of these cases we are writing down the opposite sign in here. So this becomes x minus a, this one becomes x minus c, so this one will be x minus negative b, or x plus b. Again, it doesn't matter whether that negative a sits on the left-hand side or the right-hand side of the y-axis. State what your x-intercepts are, negative a, b, and negative c, and then write out your equation. So we've got x minus negative a, or x plus a, x minus b, and x minus negative c, which would become x plus c. So in each case, we're using the opposite sign of our x-intercepts in our equation here. What about when we have a turning point which is sitting on the x-axis? Well, we read this as what's called a repeated factor. So again, our x-intercepts are a and b, and so our equation is y equals k, dilation factor, x minus a, and x minus b. But where we have our turning point, we're going to have a repeated factor. So what I'm going to do here is put a power of 2 on this base of x minus b. The last trick that assessors might throw at you, be it your teachers or the examiners at the end of the year, is to make the polynomial itself negative. If this happens, try not to let it throw you. Go back to the basics that we've just been practicing. The x-intercepts are negative a and negative b, so therefore our equation is k, x plus a, x plus b. Account for your repeated factor, and then what we're going to do is stick a negative out the front because we know that this equation or this graph is a negative cubic. The thing though is if this is a multiple choice question, you might not have this as an option in your solution set. So instead what they might do is take that negative that's sitting out the front there and put it into one of the brackets there. So in this case I've changed x plus b into negative x minus b. You should be able to find lots of examples of these, both in your textbook and certainly across the last number of years of past VCAA papers. Check out the VCAA website to download some of these past papers.